Good evening, folks. So, we're here tonight to study for the final. First of all, I'll say we're going to go over this question just to give people who are coming in uh, a little bit of time to show up, and then I will open it up to whatever questions people have, and then we'll see how long that goes. Okay, but first let's take. This should be F, or that should be H, one of those. First, let's take the second derivative of this. So this is going to be a product rule question. Like this. And it probably will really help if before we go much further, we FOIL out what A is. So this is 4x squared plus 12x plus 9. Okay, so then A prime is 8x plus 12. B prime is e to the x. And so then if I go ahead and write down the first derivative, it's going to work out to be A prime B, so 8x plus 12 times e to the x plus AB prime, so that would be plus 4x squared plus 12x plus 9 times e to the x. Okay. I think people have gotten pretty used to the factor out the e to the x trick, which is going to make our life a little bit easier. So I can combine the 12x and the 8x plus 20x. Combine the 9 and the 12 to get a plus 21. Okay. And I'm simplifying this because the question asked for the second derivative. So I'm going to take the second derivative. So I want to simplify the first derivative as much as possible before I go about taking the second derivative. Okay. So now I'm set up to let A be e to the x, B be 4x squared plus 20x plus 21. A prime is e to the x. B prime is 8x plus 20. So F double prime of x is e to the x times 4x squared plus 20x plus 21 plus e to the x times 8x plus 20, which looks like e to the x times 4x squared plus 28x plus 41. So then when we go ahead and plug in 2, out that f double prime of 2 is e squared times 16 plus 56 plus 41, okay, which will work out to be 97, 107, 113. Okay, so if you have questions about this example, by all means ask them. If there's a lull later and people want some more examples, I've got a huge pile of these that we'll go over. But anyway, just to remind you the structure of this week. So we had sample final A due yesterday. We have sample final C due today. I expect there'll probably be a lot of questions about both of those tonight, which is fine. There'll be one more sample final, which will be due on Thursday. It'll be posted tomorrow evening. But my advice for tonight is that for studying, you should go over the 6 previous tests and remember questions that you got right and questions that you got wrong. Just review those. They're still posted on Katie, so you can go back and look at them. I have finished grading test 6, so that should all be posted. You should have an approximate version of your grade in the class there. Remember, the default is that you'll take the final on Friday, but if you want to take the final before then, let me know, and I can let you take the final either tomorrow or Thursday as well. Okay, and I see I've already got some questions coming in. Before I get to questions about math, are there any questions about the schedule this week or the bureaucratic stuff or any of that sort of thing? Okay, well, if anything comes up, let me know. I'm going to start out. Let's pull up 11 to start with. That was the first request. 11 from C or 11 from A? I guess they're similar enough. I'll do 11 from C. So here's 11 from C. So here's a graph of our function. And so it wants us to approximate f prime of minus 2. And what we're really going to have to do to approximate f prime of minus 2 is sketch in an approximation of what the tangent line at minus 2 looks like. Because remember, f prime of minus 2 is just the slope of the tangent line at minus 2. Okay. And so you can sketch this in, and then you want to sort of eyeball some points that look like they're on this line. Like, for example, you might guess that that point is minus 2, 0.5. And then you might guess that this point is something like minus 3, 0. And then you can calculate the slope between these 2 points as 0.5 minus 0 divided by minus 2 minus minus 3, which will be 0.5. And so you'll get that the derivative here is approximately 1/2, or 0.5, however you want to write it. So that will be that question. Next, we're asked about the limit as x goes to minus 1 of f of x. So for that, we're going to look at the graph to the left and to the right of minus 1, okay, which is going to bring us to this point right here, the hole as it happens to be. And so this limit is going to take the value 2. It's the y value of this hole. Okay. Note, if I asked you what f of minus 1 was, f of minus 1 would be 3. But the limit is 2. Next up, we have the limit as x goes to 2 from the right of f of x. So here's 2. And we're supposed to be looking only from the right, so that is from this side. And so that's going to bring me to this point up here, where the y value is 5. So the limit as x goes to 2 from the right of f of x is going to be 5. Okay, before I talk about the next piece, I want to ask, are there any questions about so far about these pieces about the limits? Okay, hearing no questions, I will talk about part 4. So in this case, I see one vertical asymptote, which is here. That's x equals 4. and I see one horizontal asymptote, which is here. That's y equals 0. Okay. Those I really just have to read off the graph, making sure I know what vertical and horizontal asymptotes look like in the graph. Last piece of question 11 is to approximate the coordinates of a critical point. Remember, a critical point is a spot where there's a horizontal tangent line. In this graph, there is exactly one of those, which is namely that one. And so as a result, the only answer I could actually write for this one is 1 minus 2. Oh, I realize I wrote that in a place where you can't actually see it on the screen, which is probably not helpful. Okay. So that's question 11. Reminder, by the way, this whole video, as well as last night's version of this, if you haven't looked at it, will be posted to the YouTube channel. So if you realize you missed something, or if you want to look over and see what questions people asked last night, you can hop onto the YouTube channel and you can look through it and see what got posted. And also, you're welcome to come tomorrow night if you are so inclined to ask more questions. Okay, let's talk about 12. So 12, the key difference here is that in 12, we're given a graph of the derivative. So I want to circle the word derivative, but it needs to be on the screen first. Okay. So that means I need to keep in mind I'm not looking at a graph of f. So all of these questions are about f, but I can't actually see a graph of f. Okay. So I want to look for where the critical numbers of f are. Okay. And remember that what makes something a critical number is that the derivative there is 0. So this is the derivative. So I'm really looking for x-intercepts. So namely, -3, 0, 2, and 5. Those will be my critical numbers. Okay. Note how very different this question that asks about critical numbers is from the previous question that asked about critical numbers, where we were looking for this point with a horizontal tangent line. And the reason why this is so different is that instead of looking at a graph of the function as we were here, we're now looking at a graph of the derivative. So pay close attention to that distinction. Okay, so that is the first part of 12. For the second question on 12, we're supposed to classify the critical numbers. So here's one. What happens here at -3? The derivative switches from negative to positive, which, if you remember, that means that the function itself switches from decreasing to increasing, meaning it has that shape. So this is a local min. The exact same thing happens over here at 5. At 0, what happens here is the derivative switches from positive to negative, which is going to force that kind of shape, which is to say that at 0, there is a local max. And then at 2, the derivative is actually negative on both sides, so the graph ends up looking something like that, which is a kink. And it's that shape of kink if you want to be specific. The next question asks, on what intervals is the function increasing? And so how do I read that from the derivative? I remember that an increasing function corresponds to a positive derivative. So I'm really asking in this question where in this graph the function is positive, which happens to be from -3 to 0, and then from 5 to 6. Or if you preferred, you could write 5 out to infinity, depending on exactly how much you think you know about what this function does as it goes off the edge of the graph. Four asks, where is the graph increasing the fastest? Or where is f of x, increasing the fastest? And so how fast something is increasing is a matter of how big its slope is. This is a graph of the slope, so this is actually describing this point up here at the peak of this graph. And so that input looks to be about minus 1.8-ish. A little short of -2. Last up, it asks about the equation of the tangent line. So I'm going to go ahead and switch back to zoomed out mode. And so this is C12.5. Okay, so we want the tangent line, and it tells us that f of -2 is 7. Okay. So it then asks for the equation of the tangent line. Okay. So you might be inclined, upon looking at this for the first time, to say, wait a minute, f of -2 isn't 7. I can read it in the graph. It's 6. Okay. But remember, this is not a graph of f. This is a graph of f prime. So I actually can't say anything about the value of f from the graph of the derivative. I don't know if it's positive or negative or what. No idea. So that's why I had to tell you in the question, f of -2 is 7. Okay. So f of -2 is 7. That tells me that on the tangent line, I get the point -2, 7. Okay. I also know the slope is going to be given by f prime of -2, because that's what a derivative does. And in fact, this is where I use the fact that I was given a graph of the derivative. Namely, when I look at this graph, and I know that this graph is the derivative, I can read off that f prime of -2 is in fact 6. Okay. So that means my tangent line looks like y equals 6x plus b. But also it passes through -2, 7, so I can plug that in. Okay. So that tells me that b is 19. And so the equation of my tangent line here is y equals 6x plus 19. Okay, so there's a bunch more questions here so far. But before I get to those questions, are there any clarifications? I just went over 10 different pieces of 11 and 12. Is there anything from 11 and 12 that people want me to talk about more or go over again or anything like that? Okay. Well, the next request was about C9. So C9 gives us this graph of the function f of x equals the square root of 11 minus x minus the square root of 4x plus 1 divided by x minus 2. Okay. And it shows us this graph just to remind us that this graph has a hole in it, but it asks where this hole is. Okay. And remember, holes in graphs come from one place. Namely, holes in graphs they always come from these places where the function evaluates to 0 over 0. So where does this function evaluate to 0 over 0? Well, in this case, the denominator is actually x minus 2, so the denominator is only 0 at one place, namely at x equals 2. Now note, if you plug in x equals 2 to the numerator, it gives you square root of 9 minus square root of 9. So namely, if I did plug in 2 to this function, I would literally get 0 over 0. Okay. So that's the x-coordinate of the point. How do I get the y-coordinate of the point? Well, I get the y-coordinate of the point by using limits. Namely, the y-coordinate here is going to be the limit as x goes to 2 of this thing. Okay, and this is one of these ones that has square roots floating around. So I handle this by multiplying by the conjugate. Which, if I go ahead and multiply this out, the numerator is going to be 11 minus x minus 4x minus 1. And the denominator will be just x minus 2 times that whole mess. Okay, so the numerator here will work out to be 10 minus 5x divided by x minus 2 times the sum of these two square roots. Okay, it would now be in my interest to factor the numerator. So I will do that. And now notice we have an x minus 2 in both the numerator and the denominator. And so you probably remember this was the central theme of everything we did with limits, was finding this x minus 2 in the numerator to cancel with the x minus 2 in the denominator, so that now I'm no longer looking at something that's 0 over 0, and instead I'm looking at something that is going to be minus 5 divided by 3 plus 3, which is minus 5 over 6. And so that is the y-coordinate of the hole in this graph. The next question is about 8 from A, but while I look up what 8 from A asks, If anyone has any questions about this solution to question 9, let me know. Okay, seeing no questions about that, let's talk about 8 from A. Okay, so here is our function. Okay, and we want to know intervals of increasing, decreasing. So we need a derivative before we can use a first derivative test. So I'm going to need to use the quotient rule here. About a quarter of you are still doing the quotient rule wrong because you're writing the formula in the numerator in the wrong direction. So I want to remind you, whenever you're using the quotient rule, it is always a prime b minus ab prime over b squared. You cannot flip the order and do it in the other way, because that will give you negative of the answer, which, when you're doing a first derivative test question, as many of you were doing on the test you just got back, will then give you exactly the opposite answer to every part of the question. Okay, so a prime here is 6x plus 5. B prime is e to the x. So the derivative is 6x plus 5 times e to the x minus 3x squared plus 5x minus 5 times e to the x, all divided by e to the x squared. Okay. Now is a fantastic time to notice that there is an e to the x in every term in the denominator, an e to the x in every term in the numerator, and there's 2 e to the x's in the denominator, so I can actually cancel the e to the x's in the numerator with one of the e to the x's in the denominator, which is going to leave me with actually minus 3x squared plus x plus 10 divided by just 1 e to the x. I'm going to factor a minus out of the front of this to make factoring it a little bit easier. Okay, so this is minus. I'll do this on the next line. Okay, so I want to say this factors like this. Okay, and notice, because this is a first derivative test question, I have not set anything equal to 0 yet. I have simplified the first derivative as completely as possible before doing that, because I'm going to need to put stuff back into the first derivative as part of executing the test. Okay. So, now though, I am ready to go hunting for critical numbers, And I will find those critical numbers by setting the numerator of this fraction equal to 0. And that will give me as critical numbers x equals minus 5/3 and x equals 2, which I use to form my number line where I put these things on it. And so this I'm supposed to label f prime of x. And I need to pick a test point here in each interval. And I need to go ahead and actually plug each of these things into the derivative, each of the test points. And by the way, be sure you show this work. A lot of people on the final seemed to just pull these things out of nowhere. You have to actually show, okay, f prime of 3 is what? And so it will be minus 9 plus 5 times 3 minus 2 divided by e cubed, okay, which is minus a positive times a positive divided by a positive. So in other words, it is negative. F prime of 0 is 10. That is positive. And f prime of minus 2, that will be minus 6 plus 5 times minus 2 divided by e to the minus 2. Okay. Remember, e to every power is positive, so e to minus 2 is definitely positive. Okay. But then this is negative, this is negative, this is negative. 3 negatives multiplied together will give me a negative. Having done that, I can translate everything back over to information about f itself. Namely, positive derivative means increasing, negative derivative means decreasing. And so I can write down that this function is increasing on minus 5/3 to 2, and decreasing on minus infinity to minus 5/3 and 2 out to infinity. Okay. And so the question just asked that, so that's the full answer. But just since we're here anyway, if the question had asked, this takes the shape of a local min, and this takes the shape of a local max, so this would be a local min, this would be a local max. Okay, if you have any questions about this first derivative test question, let me know while I dig up the next question, which looks like it is going to be 5 from test C. Five from test C, by coincidence, is almost identical to the question we just did. So we have here a graph, and we have this function x squared minus 3 over e to the x, and we're asked to find these 2 points, this one and this one. So we have to look at what's special about them. Okay. this point, this is a vanilla x-intercept. Just like all the way back on test 1, we could have had this question. This point here, this is a critical point. So to do this question, I'm going to have to find the x-intercepts of f, the critical points of f, and then I'm going to have to decide which x-intercept this is and which critical point this is. Okay, let's look at x-intercepts first. Okay, remember for x-intercepts, we're looking for where the function is 0. In this case, the function's a fraction, so I'm looking for where the fraction is 0. So I'm looking for x squared minus 3 being equal to 0. Just the numerator, because I'm looking for the fraction being 0, which gives me x squared is 3. So x is plus root 3, or x is minus root 3. Yeah. Hopefully by now, one of the things that's been emphasized enough times that you're doing it consistently is that if you have x squared equals something, you get two solutions, one with one plus and one minus. If I look back at the graph, I know which one this has to be, because this point is to the left of the y-axis, so it has a negative x. And so the first point there had better be minus root 3 comma 0. Okay, the critical point is next. So for that, I'm going to need to take the derivative. And so after taking this derivative, I'm going to get that f prime of x is 2x times e to the x minus x squared minus 3 times e to the x divided by e to the x times e to the x. Exactly as in the previous example, there's an e to the x in every term in the numerator, so I can cancel them. And so this is going to work out to be minus x squared plus 2x plus 3 over e to the x. If I factor the minus out front, the x minus 3 times x plus 1. Okay, and so then when I look for when that's 0, then I get that my critical numbers here are 3 and minus 1. Okay. But looking at the graph, the x-coordinate of this point is definitely negative, so it has to be x equals minus 1. And then to get the y-coordinate, I plug that minus 1 back into the original equation, which will give me, sorry, I'll do that here. F of minus 1 is 1 minus 3 over e to the minus 1, which will give me minus 2e. Do be sure on the final and such, you're simplifying your answers to something that looks like this. You shouldn't be leaving an e to the minus 1 in the denominator like that. Okay, so those are the 2 points that we're looking for here in question 5. Okay. If you have questions about this, let me know. I'm going to hop on over to question 4 from C as well. Okay, so 4C4. Okay, this one is about the function 2x cubed plus 5x squared plus 2x. So when I look at the graph, I see that what's going on here involves these two lines. I'll go ahead and dash one of them in red and one of them in blue. So the point I'm interested in finding, the point that's labeled question mark, it's on the blue line. But I'm only going to figure out information about the blue line by figuring out stuff about the red line first. And so the key observation here is that the blue and red lines are perpendicular. And the fact that these two lines are perpendicular tells me that once I know the slope of one, I know the slope of the other via that whole negative reciprocal formula. Okay, so let's work with the red line first. So here, f prime of x is 6x squared plus 10x plus 2. And so the slope of the red line is f prime of minus 1. It's minus 1 because that's how the point where this is the tangent line is labeled, by the way. Not for any deep or profound reason. This is 6 minus 10 plus 2, which is minus 2. Now, probably the first time you sat down to do this question, you're going to sort of reflexively find the equation of the red line, because you know how to do that. But I don't actually need the equation of the red line. I only need the slope of the red line. So once I have that, I now know the slope of the blue line, because it's perpendicular. So the blue line now has slope 1/2. Okay. And I just got that by using the formula that the slope of a perpendicular line is negative the reciprocal of the slope of the first line. So now I need to figure out how I'm going to go from knowing that the slope of the blue line is 1/2 to knowing what the point question mark is. But here's the key point. The slope of the blue line is the derivative at that point. So the point I'm looking for is the point where the derivative of this function is 1/2. So namely, I'm trying to solve the equation that the derivative is 1/2. I want to find out where does that happen. I can make my life considerably more pleasant by doubling everything first to clear out the denominator here. Okay, and now there's a few possibilities I have to dig through. in order to find this. But after a little bit of searching, I find this is the correct factorization. And so that will give me two values for x, minus 1/6 or minus 2/3. Sorry, minus 3/2. Again, it's very helpful to look at the picture to decide which of these two it has to be that I'm actually looking for. Okay. And there's two real ways you could do that. One is to say, well, this point is labeled as minus 1, 1, and the x-coordinate of this point that I'm looking for is more negative. And so as a result, this one has to be the one that's less than minus 1, so it's that one. Alternatively, you could look at the other point where this slope is this. Pretend those are parallel. This would be the point that's closer to 0, so that's the one with x being minus 1/6. And so either way, you get that this point has x equals minus 3/2. Okay. And then the second piece here, you'll get by finding f of minus 3/2. Note it's f, not f prime. And I'll leave you to do that so that I can talk about other questions, because I see there's still a number of requests. Okay, so next I'll talk about 3 from C. Okay, so here's our function. Oh, and we want the tangent line. Okay. So before we delve any deeper, let's write down our point. The x-coordinate is 36. The y-coordinate is going to be what I get by plugging this input 36 into the function, which is going to give me 12 divided by 6, which is 2. Okay. Again, this 2, it's just f of 36, nothing fancy. Okay. The slope of this line is going to be f prime of 36. But before I can get to f prime of 36, I need to figure out what f prime of x is. To figure that out, I probably want to rewrite f of x as 12 times x to the minus 1/2 power. This is so that I can use the quotient rule, this is so that I can use the power rule and not have to use the quotient rule to take the derivative of this thing. Okay, so this will work out to be minus 6x to the minus 3/2. Okay. So going back to that bit about the slope, my slope here is minus 6 times 36 to the minus 3/2. And I have to spend a moment to remember everything we learned about fractional powers. So the minus puts this in the denominator. And then raising something to the 3/2 power, remember, is the square root cubed. Okay, so this is minus 6 divided by 6 cubed. I can cancel one of the 6's, so this is minus 1 over 36. Again, be sure you're being careful to keep everything exact, so don't give me an ugly decimal version of this. I want to see that you have learned how to handle all of these exponents and this kind of thing on the final. Okay. So, we're almost there. So, the equation of the tangent line looks like this, but we can plug in our point. Okay, that actually works out pretty nice. And so my answer here is y is minus 1/36 x plus 3. Oops. Okay. Next up, someone asks about 14 from C. Okay, so here is C14. Okay, so this is a question about apples, wherein we want to know basically how much fertilizer to use. And so we're looking at our yield of apples in terms of the amount of fertilizer. Okay. So the input here is how many crates of fertilizer are used. And the output is how many bushels, how many thousands of bushels of apples are produced. That is not a possessive. I don't know why I put that there. Okay, so we have some questions about the derivative. Before I can take the derivative, I need to sort of FOIL this out. So minus f squared. Let's see, there's times 30. Yeah, so plus 20f. And then plus 300. As it happens to work out, minus 12f squared plus 240f plus 3600. So a prime of f then is going to be minus 24f plus 240. Okay. And so it then asks us to consider two different values of the derivative, namely a prime of 0, which is 240, and a prime of 15, which as it happens will be minus 120. And the units of both of these are thousands of apples per crate. So remember, derivatives are always telling us about change. So when you look at something like a prime of 0 and see that it's telling you that's 240, this is telling you how the output of this function will change with the input. In other words, the input here is an amount of crates of fertilizer. If I increase the number of crates of fertilizers, how quickly will the output increase? And so what this means is something like that in an unfertilized orchard, the first crates that we add bring 240,000 extra bushels per crate. So that's great. Seems good. One box of fertilizer gets us 240,000 extra bushels of apples. Sounds like a good deal. But then when you skip over and look at a prime of 15, okay, this is at a different base point. This means that when currently using 15 crates, then using additional crates actually decreases the amount of bushels of apples that we make. And I know it's decreases because this derivative is negative. Okay, so this is telling us fertilizer is good. If I use fertilizer, starting with my unfertilized orchard, and I use the word unfertilized again just to re-emphasize the fact that this blue blurb here is talking about a prime of 0, that is starting from a baseline of no fertilizer, that gets us lots of extra apples. However, there is such a thing as too much fertilizer. Indeed, by the time we're using 15 crates of fertilizer, extra fertilizer actually poisons our apple trees and we make fewer apples. Okay. And so the business conclusion here is actually pretty precise. 15 is too many crates of fertilizer. Okay. We definitely need to use more than 0, less than 15. Okay, so that is question 14 from C. I know it's 7, so feel free to leave if you like, but someone asked about question 7. I'm going to definitely go over that and then see if anyone has anything else they want to talk about. And if not, I will see you later. You'll be getting an email, by the way, asking about course evaluations. I know this is a bit of a weird course to analyze given the settings, but I'll send you an email about that as well. But let's look at 7. Feel free to come back tomorrow night, by the way, for those of you who are wandering off. Okay, C7 gives us the function 12x over 2x minus 1 squared. Okay, and asks us to find the max and min values on the interval minus 6 to 0. Okay, so we need to take the derivative here. Okay, so here the derivative is going to work out to be 12 times 2x minus 1 squared minus 12x times 8x minus 4, which I'm going to go ahead and notice is 4 times 2x minus 1, because it'll make my life a little bit easier. Okay, so if I write this out, this is going to be 12 times this, so this will be 48x squared minus 48x plus 12 minus, and then this will be 96x squared plus 48x. Did I do that right? Yeah, that looks right. Okay, so over 2x minus 1 to the 4th. Okay, which is going to be minus 48x squared plus 12? What did I do wrong here? I feel like I did something wrong. I'm going to cheat and look at my sheet so that you don't have to watch me do this. Oh, no, it's right. Never mind. Sorry. Divided by 2x minus 1 to the 4th power. Okay. And I can definitely factor a 12 out of this. So I will do that. Sorry, I won't factor that out. Minus 4x squared plus 1. Okay, so I want to know when this is 0, because I need to know my critical numbers. So I'm really looking at a fraction. I only really need to look at this piece. So I want to know when is minus 4x squared plus 1 equal to 0, which is to say when is x squared equal to 1/4, which is to say x is 1/2 or x is minus 1/2. This one's not in the interval. So I only actually need to look at 1/2. Okay. So then I need to calculate f of minus 6 f of minus a half and f of 0. And I need to figure out which of these is the biggest and which of these is the smallest. I'll leave that piece to you. Okay. Okay, 13 and then 6 we have requests for. I will happily do those. Let's figure out what they are. Okay, so 13 gives us this picture. Something like this. Okay, and just as before, just to keep track of what's going on, I'm going to go ahead and draw in the lines in different colors just so I can refer to them. Okay. And note these two lines are parallel, so they have the same slope. And I suppose I should mention that the function here is 2x plus 3 times x minus 2. It'll make my life easier if I go ahead and note what the 2 points are. Namely, these 2 points, these are x-intercepts. So this point is 2, 0. And this point is minus 3/2, 0. Note, I get those points just by looking at where the original function is equal to 0. Those are places where the original function crosses the x-axis. Okay, so I had to FOIL this out. So this is going to be 2x squared plus 3x minus 4x is minus x minus 6. So f prime of x will be 4x minus 1. That lets us find the slope of the red line because the red line is the tangent line at minus 3/2. So the red slope is f prime of minus 3/2, which is 4 times minus 3/2 minus 1, which is minus 6 minus 1, which is minus 7. Now, by virtue of the fact that these two lines are parallel, this is also the blue slope. So originally, I have both of these lines, but this blue line's not a tangent line. So I don't have any way to directly find the slope of the blue line, but I can directly find the slope of the red line because it's a tangent line, so its slope is given by the value of the derivative at the input. But because the lines are parallel, they have the same slope, And so now I can actually go ahead and find the equation of the blue line. So the blue line, it looks like y equals minus 7x plus b, but it passes through the point to 0, so I can plug that in. So that will give me that b is 14. Okay, so the blue line has as its equation y equals minus 7x plus 14. Okay. I realized when I drew my picture, I actually didn't say what the question was. The question is to figure out when the blue line actually intersects the graph. And the blue line actually intersects the graph. I find that by setting the two of these equal to each other. The equation of the original graph and the equation of the blue line. So I solve 2x squared minus x minus 6 equals minus 7x plus 14, which should give me 2x squared. If I add 7x to both sides, I'll get plus 6x. Subtract 14 from both sides, I'll get minus 20. I can divide through by 2. And so then I will get minus 2 and plus 5. Okay. So this is the intersection at x equals 2. That's definitely not the one I want. So I'm looking for the intersection that happens with x being minus 5. And so the point I'm actually looking for ends up being minus 5, comma. And then, as always, to get the y-coordinate, I plug minus 5 into the original function, or into this line. And so either way, I'll get that it works out to be 39. Okay, so that was 13. Okay. So after 13, I promised 6. Okay, so I'll try and reproduce the original graph first. I realized this was supposed to stop here. Okay, so there's my approximation of this graph. Okay. When we go to find the derivative, I want to mark off all the points where something changes, like this one, that one, as well as all of the points where the derivative is 0. Oh, this point was really supposed to be over here, but I'll roll with it. But the actual graph has this point a little bit further over. So these spots where the derivative is 0 give you directly points on the graph of the derivative. So that and that are points on the graph of the derivative. Okay, so let's figure out what the derivative of the red piece looks like now. So when you look at the derivative of the red piece, between these two dots, I see it starts out as 0 and then starts increasing, so the derivative gets positive until somewhere in the middle where it starts slowing down and the derivative is still positive but becomes less and less positive. So that will end up looking like that. And if you look over what happens then, it's sort of on the outside coming over here. It's going to look something like that and like that, roughly speaking. Okay. So that's the red piece. It's going to end up looking something like that. Now, the black lines are actually easier because the derivative of a line is a constant. It's just the slope of the line. Okay. So all I need to do is draw a horizontal line where I think the slope of this black line is. Okay. Now, if you notice the way I sort of drew this, or maybe better, look at the original picture, the slope of the black line blends perfectly into the slope of the red part of the graph. So those slopes actually match. So that means when I go to draw this derivative, I need to go and draw something over here. This is supposed to be horizontal. It doesn't look that horizontal, but we'll pretend that it's horizontal. Okay. And so again, the fact that these overlap here at this point is communicating the fact that this line met up at the same slope with the graph here. That exact thing, though, does not happen here. Okay. In fact, actually, what you see at this point, in either rendition of this graph, is that the function was actually, the red part was decreasing faster, and then when it breaks into the black line, it's suddenly decreasing slower. So instead of there being a nice connection, this derivative is actually closer to 0. Again, this is supposed to be horizontal. Apologies. And so that is how I end up doing this question. Okay. And so the key thing is the middle, the derivative in the middle ends up looking like this kind of U piece, which connects to a horizontal line on the left, but then there's this jump on the right with these holes in the graph of the derivative. So that's what that should end up looking like. Okay, I see someone pointed out we already did 9 today. Are there any other questions that people want to look at before we adjourn for the night? Remember, as always, this will be posted so you can look back at it later. There'll be another version tomorrow night, which you can come to if you want and get questions answered. Or if you prefer, you can just look at it later, see what questions people asked. And then we'll do this again on Thursday. As always, there are office hours, so come by tomorrow 10 to 11:30 if you have more questions and want to go over them. But if not, it looks like no one else is rushing to ask any more questions, so we'll wrap up there for tonight. Have a wonderful evening. Oh yes, math clinic tonight. Don't forget math clinic tonight. Yes, also that. Unless there's not. But no one told me there's not, so there should be. All right. Have a good night, everyone. Stay safe, be careful, and I'll talk to you tomorrow or the next day.